Hello there, I am Dr. C.N. Okolubo. You're welcome to my YouTube channel where we'll be solving problems relating to business mathematics, business statistics, analysis for business decision, as well as other related topics. I want to encourage you as you go through these videos with me, you have your paper, your pen, and your calculator to solve these problems with me. Also, please do like, share, and subscribe so that you can receive notifications for upcoming videos that we'll be uploading. Thank you. You're welcome once again to my channel, and today we are going to look at something different, a different perspective to normal probability distribution. Before now, from our earlier videos, we have looked at a situation where you will be given a value, then you will have to find the probability of meeting those criteria. But this time around, we are going to reverse the table by giving the probability of picking somebody within a particular range. Then we have to find the values that represent that probability. So it's like working our way backwards from where we started before to where we end in looking at the values in the distribution table. This time around, we are going to look for the values in the distribution table. We are going to look for the probability first, representing that, then we will work our way back to finding the values that represent the probability. I trust you understand what I'm saying. So, but let's look at an example on the board what we have. I will really encourage you that before you get to example 6, if it is the first video you're watching, please look for examples 1 to 5 so that you can establish your knowledge and understanding of normal probability distribution. Then before you can look at this, because this will be a little confusing to you as we look at this example. You go back to those other videos so that you can establish yourself and your knowledge in normal probability distribution. Let's look at what we have for this lecture series and lecture session. First, now let's look at this example 6. And the question is, in a survey, graduates' earnings have a mean of 60,000 and standard deviation of 15,000. What range of values represents the top 15%? That's 1. B, the bottom 35%. And C, less than 75%. How do we solve this kind of challenge? Now, remember, when we talk about probabilities are represented by proportions. As you see in the probability distribution table, there is a proportion 0.1, 0.2, 0.5, 0.84, whatever. Now, these values can be converted to percentages by multiplying by 100. So we are going to try and represent these values once again in fractional point. Then we will now work back to finding the data point or the values that we are looking for. Let's look at this first example. We're looking at what to find what represents the top 15%. So the first thing we do in finding this solution is the top 15%. Now, how do we represent top 15% in our normal curve? Let's draw a normal curve like this. Then we have this. Now, the mean we're told is 60. The mean is 60. And we're looking for the top 15%. Top 15%, top being ahead of 60. Top 15 is going to be ahead. So it's going to be on the side of our normal curve. So we're going to say top 15% or greater than 50%. Now, what are we going to do now? Top 15 means from here, from this 15, from this point of 15, and also we're going to shape this dimension of our table. Now, what are we going to look for in our normal distribution table to represent top 15? Now, this 15% can be written as 0.15. I trust you understand this. It can be written as 0.15. But mind you, we have two tags here. We're looking for what represents top 15%. So we have to look for values at this point before we know what to do. And to get this value here, as we did in the other examples we were looking for, if you're looking at a 50% normal distribution table, we'll be looking for values from this point, this mean point to this data point. Then whatever we get is done from 0.05. And just to remember that that's what we'll be doing. We look for values from here to here and we deduct from here. So the same way that will also apply. In the sense that for us to get what will be top 15 from this point, we now have to find what we represent here to here. If this point is top 15, then what will be this point to this point? To what? 35%. If this point, don't follow me, if this point to this point ahead is top 15, that means from here to here will be 0.35, because the whole of this is 50%. The whole of it, which is equal to 0.5. So we will deduct 0.15 from what? From 0. And that will give us if we were to use a total distribution table, we'll be looking for the values that will represent 1 minus 0.15, because we're looking for the whole of this to this point. Then we're looking for what is within top 15. So that's why we deduct 1 from 0.05 and we'll be looking for 0.03. What do we do with these values of 0.05 or 0.35 and what do we do for this value of 0.85? Now, this is where the tax comes in. We now have to go to our normal distribution table and find the values that represent, that is closest to 0.35. We'll look for the value that lie closest to 0.35, and in the total distribution table, we'll look for values that is closest to 0.35. Can you come along with me to our normal distribution table? Because we want, when we find that value, the value we are going to look for that is closest to 0.05, we'll look for the position in the normal distribution table. That value becomes our z-score. The value becomes that. Follow me very quickly. We're looking for 0.35, something that is closest to 0.35. Please follow me here. We're looking at this whole values are probabilities or percentages. So we're looking for the one that is closest to 0.35. As you can see here, this is 0.35. We already reached 0.35, so we won't pick this one. We'll pick the very next value. We'll pick the very next one before 0.35. In some text, they will say go to the middle, but for me, I'll just go by this exact value. So where is 0.3485, which is the next value to 0.35? Where is it lying? It is lying at row 1.0 under column 0.03. Remember, look at it. It's lying. This is the closest value to 0.35. Do you see that? It's lying at row 1.3 and then 0.03. So that makes it 1.3. 0. Look, follow me here, please. It's 1.0 plus 0. This is 0.1, 0.1, and you have 0.03. So that's what we have. So that gives us 0.13. That equals 0.1. No, I think I'm making a mistake here. Please come back. Come back. What we have here is this. Okay, what we have here is this 1.0 to 0.03. So 1.0 plus, so 1.0, sorry, this is 1.0 to 0.0. So this is 1. That's the z-score we're going to use. This z-score we're going to use. Come back again to look at the total distribution table. We are looking for the value that is closest to 0.85. 0.85 is following 0.85. We're looking for something closest to 0.85. Somewhere here, 0.85. Okay, this 0.85. But we're looking for the value that is closest to 0.85. Look at it. Look at the value that is closest. This is 0.85. But we're looking for the value that is closest to 0.85. And it is lying at where? 1.0. And then under this. So it's the same thing. So we have 1.0 under 0.03. So that means our z-score will be 1.0. So remember, when we were solving value for z-score, we had z-score as z equals to x minus mean all over standard deviation. So in this case, we're going to have 1.03 equals to x minus mean is 60, that's 60,000, divided by 15,000. So as you can see, our take this up here, then have 1.03 equals to x minus 60 all over 15. So now let's cross multiply. Let's cross multiply this value. We will have 15 times 1.03 equals to x. Remember, we're looking for x minus 60. And then this value, 15 times 1.03, will give us 15.45 equals to x minus 60. Now to find x, we will move 60 over to the side. So this becomes 15.45 plus 60. This becomes x. So if we add this up, what are we going to have? We're going to have 75.45 equals to x. Now let's multiply this value times 1,000. Then we remove the 1,000 value. So this will be 75.45 times 1,000 times 1,000. That will be 75,450. So which means that those that are having the top 50 earnings of this group are earning more than 75,450 naira. Those that are earning at the top 15 are earning more than 75,450. That represents the top 15%. Just this example is good enough for you. Let's look at the second one very quickly. The second example says that what values represent the bottom 35%. The bottom 35%. So let's have the bottom 35%. The bottom 35%. How are we going to draw that in our center again. We know our code is 60. Bottom 35 will be somewhere here. Bottom 35. So we are going to show this bottom 35%. So this is less than 35%. So the same way we did, remember, we're going to have this point to this point. That's what we're looking for. This point to this point before we find this one, or the whole of this before we find it. That means we have to less this value from 0.5. So 0.5 minus 0.35 will give us 0.15. So in the normal distribution table, we'll be looking for something closest to 0.15. Or we have in the total table, 1 minus 0.35, and that was 0.35. Looking for 0. In the normal table, we're looking at 0.35, and that will give us 0.65. So either of these we're going to be looking for. So let's go to our normal table. Let's go to our normal table and locate this value. We were looking for in the 50%. We're looking for what is closest to 0.15. Let's look for what is closest to 0.15, 0.15, 0.15. Where are you? Okay, good. You seen it? We have 0.15 here. But we're not going to pick this, we're going to pick the next value that is closest to it. And it's, what do we see? It is, we have 0.3 under 0.08. 0.3 under 0.08. Let's look at the total table. We're looking at 0.65, and we find you 0.65. This is 0.65. We're not going to pick this. We're going to pick this one, 0.648. So this is the closest value, and then it's under 0.3 to 0.08. So let's add that. We have looking at 0.3 plus 0.08. So that gives us 0.38. So this becomes our z-score. So z-score, you know the formula again. Z-score is x minus mean all over standard deviation. So our z-score, we already know that our z-score is 0.38 equals to x. We're looking for x minus 60 all over 15. We're going to cross multiply that. Mind you, another thing that I forgot is that since we're looking for something less than 0.35 and it's on the left of the curve, this value, our z-score value, will take on a negative value. The value of z-score will take on a negative value. So let's multiply this. If we want to cross multiply, you have 0.38 minus times 15 equals to x minus 60. So if you multiply this, you are going to have minus 5.70 equals to x minus 60. To find x, move 60 to the side. Move 60 to the side. So it becomes 60 minus 5.70 equals to x. So our answer will be 54.3 equals to x. Let's multiply this by 1000. If we multiply this by 1000, our answer 54.3 times 1000 will give us 54,300. So this means that the value that represents the bottom 35% are those that earn less than 54,300. So you see that we're working our way back to finding the x values there. So those that score, those that earn 54,300 are those that are earning at the bottom 35%. Let's do the last one quickly. The last solution is here, and we are asked to find less than 75%. So that less than 75% of the earners. Where will less than 75% be in our curve? We'll draw the curve like this. This here. Our mean is already here. 60 is our mean value. Less than 75%, where will it be? Less than 75% here. So we have 75%. And less than 75% will be what? Will be all of this. So we're looking for all of these values. All of these values. That's what we're looking for in this case. And it is less than 75%. Now, how are we going to solve this looking for the value in the normal distribution table? In the normal distribution table, if we're looking at the 50% table, we'll look for values between here and here, between this and this. And what we're going to be looking for, we're going to deduct 50% from 7.75 from 75%, 50%. So we're going to be looking for 0.75 minus 0.5 because that is the portion, so we're going to be 0.25. But if we are using the total distribution table, we're going to do that. It's already given the whole of this till this point. Take note that each time you're looking for the values, whether you're looking for 50% table or you're looking at the total distribution table, the difference between these values must be 50%. You see, this is the difference between this and this 50%. Come over to this side. Come over to the difference between this value 0.35 and 0.85 is what? Is 50%. Is 0.5. So the same way, let's go to the side. The same way, what you're looking for here, since you have already gotten looking for here to here, that's why we're deducting 0.25 because we're using the 50% table. But if you're using the total division table, you use the whole, so you have 75%. Now let's go and look for the previous value to 0.25 so that we can find our z-score. Come along with me. So in our 50% table, let's look for the value that is closest to 0.25. 0.25. Okay, we have 0.25 here, but we're not going to pick this value. We're going to pick this one. We're going to pick 0.2486, and 0.2486 is lying at row 0.6. Are you with me? 0.6 under 0.07. 0.6 under 0.07. Come along with me here. So we have 0.6 under 0.07. So that our z-score will be 0.67. This will be the z-score. So let's go to solving this problem. We know that z-score is x minus mean divided by our standard deviation. So we're given the z-score 0.67 equals to x value, we don't know x value, minus 60 divided by 15. So let's cross multiply. If we cross multiply, we have 0.67 times 15 equals to x minus 60. So if we multiply this, if we multiply our 0.67 to 15, what we're going to have will be 10.05, which is equal to x minus 60. So to get x, we'll move 60 to this side. So this becomes 10.05 plus 60. So this is x. So if you add this up, then we have 70.05. Now let's multiply this 70.05 times 100. This will give us 70,059. So this will give us 70,050. Now, which means that those who are earning less than 75% of the earners, then earn less than 70,059. Now, this makes a lot of sense, in the sense that if you look at this solution that we have, if we say if the mean is at the center, and we're wanting those that are earning less than 75, the value should be greater than our mean of 70. The same way, if we say we're looking for values bottom 35%, bottom 35, this mean is at the center, and we have these values. So what we are going to have is going to be at the bottom, we're going to be less than the mean. That's why we have 54,300. The same way here, we have the top 15%, and then the value we have is greater than 75, greater than the mean of 60,000. Thank you very much for joining me in this session. I'll see you next time.